I am happy to have Automotive Seminars as a sponsor for the show. Now, if you're not familiar, Automotive Seminars is a diagnostic technician training company. They've got a website that there'll be a link to in the show notes. And what they offer is top-notch training to technicians like us in the field. I've been taking their training courses for years and have got a ton of benefit out of it. They've got top-notch instructors, John Thornton, Scott Shotton, Scott Manna, and every other month they've got a 2-night course that you can sign up for. Join in, ask questions, and afterwards, you've paid for the course, you can access a recorded version whenever you want. You can rewatch the class 2 years later in case you wanted some details on it, and that is a fantastic feature. So make sure to check out the website to see what courses they have available and what's coming up in the future. This podcast is brought to you by Jarhead Diagnostics. Jarhead Diagnostics manufactures in-house diagnostic equipment and storage solutions, as well as distributes for companies like Pico, ATS, and TopDon. One of my favorite tools that I've bought from Brandon and Jarhead Diag is the case for the U-scope. If you don't have a U-scope, you probably should, but if you have one, you got to get one of these 3D printed cases, has a magnet on it, has a full-size BNC lead that you can connect to, and it gets rid of the weak point of that scope, which is the mini BNC connection, which is pretty fragile. This case makes this thing nice and secure and makes it an even better tool than it was. So check out jarheaddiag.com. The link is in the show notes. This episode is brought to you by L1 Automotive Training and Keith Perkins. If you're looking for education on module programming, J2534, EEPROM work, key and immobilizer, electrical diagnostics, or drivability diagnostics, Keith has a website, l1training.com, that's got over 60 hours of training videos on all those subjects and more. When I first started out doing mobile, I utilized Keith's videos on module programming in J2534 in order to get my head wrapped around what I would need for the tooling, the computers, the software setups, what kind of obstacles I would be up against when I'm out there programming modules on cars. And it was a huge benefit to me. And I continue to use the training videos that he has on his website. So I strongly recommend checking out l1training.com. We have got Auto Rescue Tools and Isaac Rodell as a sponsor for this podcast. Hey guys, if you're looking for programming laptops, you want the laptop set up ready to go for programming control modules on vehicles, you need key cutting equipment, you need diagnostic tools, Isaac is your guy. Has all that stuff available for purchase, and the support that he offers along with the purchase has been outstanding. I bought some stuff from him in the past. I got my Dolphin key cutting tool from him several years back. And again, the support has been phenomenal. Helped me out along the way with anything additional I needed to make it work for me. Also, for the month of June 2023, they've got Autel updates for sale. So make sure to check that out as well. Again, that's autorescuetools.com. The link will be in the show notes. Welcome to the Automotive Diagnostic Podcast. We're going to explore ways to sharpen our diagnostic skills, find learning resources, and hear from experts in the automotive field. Hey, what's going on, automotive world? Welcome to another episode of the Automotive Diagnostic Podcast. My name is Sean Tipping, and I'll be your host for today's episode. Here is the deal. It is freaking hot outside. I'm up in Minnesota, and 9 months out of the year, we have the potential for snow, but it does get really, really hot around here in the summertime. And maybe it's just a matter of perspective because we're always cold, but it's very close to 100 degrees each day this past week, plenty of humidity, and it's just brutal outside. So I'm sure, depending on where you're located, you probably experience the same thing or even worse. But up here, it really starts to wear on people, customers that are driving cars. And of course, air conditioning is the number one thing that I'm getting calls for this week, and most shops are doing. And that's been the case, as long as I've been in this field. During the summertime, people will spend a lot of money to repair their air conditioning. It doesn't get used for a good portion of the year, but then once we get into the summertime around here, boy, people will dump some money into their systems. I mean, they'll fix their AC, get their AC working, and spend an easy $1,000 to do so when they need brakes and tires and ball joints that are actual safety concerns for the vehicle. They'll spend the money on the AC first because they don't want to be baking inside of their vehicle. So what I want to cover today is a little bit of air conditioning diagnosis, some vehicles that I've seen recently. I get called out when shops hit kind of a roadblock in trying to get the AC to work. Now, I actually teach the air conditioning course at school, so we walk through all the different areas, and there is a lot of different areas in the air conditioning system that have separate diagnostic strategies, right? I mean, we have, the basics, right? Like pressure, the high and the low side, and the compressor operation, and orifice tube, expansion valve, condenser, evap core, all that stuff, which I'm not really going to get into too much here today, but that's where you use your gauges. And, the trickiest thing there that you could run into is maybe a restriction in the system from a desiccant bag that's separated, or maybe a strange compressor failure where the pressures are weird. Those are really the kind of the strangest problems there. I mean, usually it's just an empty system or a low system, maybe an overcharged or an over-oiled system. But you'll see that reflected in the pressure readings on the high and the low side. Again, not really what I'm covering here. Most shops can get past that. From my experience. Of course, the other big one is leak diagnostic, and there's a whole big thing that goes into that as far as dye and refrigerant detectors, and there are other methods as well. Again, not really getting into that. I can't say in my mobile business that I've ever gotten a call to do a leak diagnosis, but I did plenty of that when I was in Firestone. And it's actually, there's a transition now. So many of you, I'm sure, are working on the newer 1234YF systems, right? And traditionally speaking, we always used the dye that we would put in with the oil or the refrigerant in the 134A systems, and then we'd run it, and then we'd look over the system with a black light, find the dye, there's your leak, okay, let's replace or fix that component. But with this transition to the 1234YF, I mean, you could use dye, you could rely on that method, but I'll tell you what, that is an expensive way to find a leak, because this stuff is, $60, $70 a pound compared to about $10 a pound for 134A. So what I'm getting at there is, if you're just going to vent out the refrigerant that you're putting in, you're going to be costing either yourself or your customer quite a bit of money if you're using the traditional dye method to find a 1234YF leak. So there are other methods. Again, I'm not really getting into leak diagnostics here. I just wanted to bring that up, is that there is a transition, and of course we can use refrigerant detectors, and there are, again, other methods as well, like using pressurized nitrogen and soapy water, things like that. So anyways, leak diagnostics, again, not too complicated. The toughest one probably being an evaporator core that's leaking and you can't get a good visual on it. That might be a little bit challenging, but again, most shops can figure this stuff out. So the third area, we got pressure diagnostics, we got leak diagnostics, but the third area, and this is where I get called into shops a lot, and what we're going to be talking about today is compressor, clutch, or solenoid operation. So what I mean by that is the compressor, the AC compressor, actually turning on and pumping refrigerant when you press that button on the dash? And
shops and customers run into situations where they do that, they hit the AC button, and it doesn't come on. Now, most commonly, it ends up being that the system is low on a charge, and the whatever module's in charge of monitoring the pressure in the system sees or is indicated by a switch of some sort that there is not enough pressure in the system, and it doesn't kick on the compressor. Okay, what's the fix? Charge up the system, find the leak, whatever you got to do. Again, most shops and technicians can figure this out pretty easily. And I'll say in all the situations that I am going to talk about today, and pretty much everyone that I run into, the system's already been charged to the proper level. It's already got enough PSI in the system, pressure in the system, to get the compressor to actually turn on and operate, but for some reason it's not doing that. And this is where technicians, I have found, kind of run into a roadblock, because there is a lot of enable criteria and sometimes several modules involved with getting the compressor to operate. It's not just that button on the dash and the compressor. There's a lot more that goes into that. And this is where maybe a lack of understanding of each individual system keeps shops and technicians from being able to diagnose these systems efficiently and accurately. So I'm going to go through a couple vehicles today, and I'll bring up just quick references to other vehicles as well, just to give you a good understanding of what you're up against when you're looking at an AC compressor that's not operating at all. It's not turning on when you hit that button. So for any AC system in a modern vehicle, one thing that you probably are aware of, but you want to be aware of, is the control module, because everything we're talking about is going to have multiple control modules involved with operation here. But the control module that's in charge of actually turning on the compressor, getting it to operate at all, is going to be your engine control module, or maybe your powertrain control module, but that's obviously controlling your engine as well. So we'll just use the term ECM, or engine control module here. He is in charge of actually turning on the compressor. So you want to know that. You probably already do, but because it's a load on the engine, when that compressor, it's belt driven, it's actually going to load down that engine. The engine control module needs to be aware of and participate in that so that it can adjust airflow to the engine or whatever else it needs to do in order to operate that compressor. So why I'm bringing that up is one of the places where I'm going to start in my diagnosis is my engine control module to see, is it even turning on the compressor? Is it attempting to turn on the compressor, because he's the guy that's in charge? Now, again, if I'm just a tech at Firestone, I'm probably going to check the pressures first, right? I'll just hook up my high and low side to my AC machine. I just want to make sure, my rule of thumb that I always had is I want to see PSI in the system equal to degrees Fahrenheit of ambient temperature. So let me give you an example, right? So if I hook up my gauges and I see 75 PSI and it's about 75 degrees outside ambient temperature, and this would be with the engine off, the compressor not running. If I see that, I know there's enough pressure in the system for the compressor to at least engage. Now, it doesn't mean it's full, doesn't mean it's charged properly, but that's enough pressure, rule of thumb, right, that the compressor should at least attempt to turn on and operate the AC. So if I see that and the compressor's not operating, okay, now I need to diagnose this clutch circuit or the solenoid circuit and see why is it not operating. Again, ECM is going to be in charge of that happening. So every vehicle I talk to you about here, and again, the ones I get called to, they have enough pressure in them. They've been charged by the shop and they hit a roadblock after that point trying to get the compressor to operate. So I'm not really going to talk too much more about the pressures in the system from here on out. So what we're looking for, and we're going to use a scan tool for this, we're going to go into the ECM as the AC system request, and it will say either AC compressor or AC compressor relay command. Okay, so and we'll just go with a relay here. AC clutch relay or compressor relay, it'll either say on or off. This is the command, what the PCM or the ECM wants the status of the compressor to be, on or off. Now, if I hit the button on the dash and I'm looking at my scan tool and the engine's running, I should see that command be on, meaning that the ECM is attempting to turn on the relay to turn on the clutch to activate the compressor, or if it's a solenoid, you'll see a different data PID, maybe a duty cycle or something like that. But you should see that status change when you hit the button. Now, if that says off when you hit the button on the dash, you hit the AC button and nothing happens, the next thing I want to look at, and this is a really important data PID that I'm sure most of you are aware of, is our AC request. Okay, so this is another data PID that you can find in just about every ECM, and what it is indicating is, did the ECM even get the request to turn on the AC? And a lot of guys miss this. Maybe you don't. Maybe you're fully aware of this and it's one of the first things you check. But I'll tell you what, this leads me to the answer, what I'm trying to get to, more often than not. And it seems to be that a lot of technicians don't even bother checking for this, using a scan tool and going into the data stream. But it's very helpful and it can eliminate a lot of checks for you just by seeing if that request is there. So let's go through some scenarios here and how I would proceed with my diagnosis of an AC system that's not working. Let's say I go in and I see that the request says yes when I hit the AC button, engine's running, system's charged. I see request yes, and then I look at the command for the relay or for the compressor and it says on. That means that ECM saw the request, that you hit the button, it recognized that, and it is trying to turn on the compressor. So now I just need to pull up the circuit for the clutch or the solenoid and diagnose that. That's it. So now I'm actually going to go under the hood and maybe I'll start at the relay. Relay is a really good place to start. If it has a traditional clutch setup, you can go right to the relay. You can look at the command side, the load side. You could jump the relay, see if the compressor turns on. I'm not going to go through that. Pretty straightforward and easy circuit there. Now, if it has a solenoid, it is a little different. We're most likely not going to have a relay in that point. A lot of times it'll just have two wires, maybe one wire right from the ECM going to a solenoid, which is really just a valve. And based on the position of that valve, it changes the displacement of the compressor. And on a lot of these clutchless AC compressors, the solenoid can get the compressor because the internals of the compressor that are connected to the pulley are always spinning, the solenoid and the valve can get it down to 0 output or 100% output. And really what it's doing in a lot of these is changing a swash plate, the angle, and so it changes the displacement of the internals of the compressor. And that's, again, really not what we're talking about here today. But if you're looking at a solenoid, it does make it a little bit different. You're going to want to check the duty cycle from the ECM to see if it's reaching the solenoid. Do keep in mind, I did a Volkswagen recently. Don't unplug the solenoid and then check it. It will recognize an open circuit, set a code, and there will be no duty cycle. And so you can misinterpret that as the ECM has failed. Well, it recognized that you unplugged it because it's doing circuit checks, and then it won't try at all. It'll set a code there, but I just want you to be aware of that. I would do your checks if you're using a scope. Actually back probe the command wire to that solenoid and see, is it getting a duty cycle, right? So again, just to sum this up, and I went a little deeper on that solenoid than I was planning on, but if you see that the request says yes, means the ECM is getting the command to turn the compressor on. And if you look at the actual command for either the relay or the solenoid and it says on or a duty cycle, it means it's attempting to. So now you just got to go to the physical circuit, figure out what's wrong. Is it a clutch? Is it a wire? Is it a solenoid? Pretty straightforward stuff there. Okay. Here's the second scenario. I see the request says yes, meaning again, that the ECM saw the request when you hit that button on the dash, but the command says no, or the duty cycle says 0 for a solenoid. So what this means is that even though the ECM saw the request that you want AC operation, it is not allowing it. Now, Be sure to check for codes here. You may have a DTC that will point you in the right direction. You might not. You might have to look through the data PIDs and understand what is the enable criteria for the compressor to operate, and what are the things that the ECM is going to be directly looking at. One of the most common, of course, is going to be your pressure sensor. Okay, and this is generally going to be the pressure sensor on the high side of the system. Could be involved on the low side. There could be a pressure switch involved here, and that's one thing to bring up is all of these systems are different. You got to pull up a diagram. You got to pull up system description operation, because everyone's going to operate a little bit differently as far as what sensor is where, or what switch is where, and what module it feeds. But some of them do, I would say a lot of the high side pressure sensors do directly feed into the PCM. And so you can look that up as well as a data PID. And you can see, is it registering enough pressure in order to turn this on? Because if it gets a request, says, yeah, okay, I recognize you hit that button, but the enable criteria is not there. There's not enough pressure or perceived pressure in the system because maybe there's a fault with the sensor. It won't turn on the compressor. Of course, you can have other things like coolant temperature that's too high, battery voltage that's too low, engine speed that's too high or low. Things like that can also inhibit the ECM from allowing that compressor to operate. So those are types of things that you need to look at. But check out the system description operation to see what's required, for the ECM to allow this, even if it gets a request from the rest of the system. Okay, so that's our second scenario. Request says yes, but the command of the relay or the solenoid says no or zero. All right, third scenario, and the one we're going to kind of focus a little bit more on today, is when we look in there. Of course, the command says off or no, and the request says no. The AC request, data PID in the ECM says no. And this is what I run into a lot. I seem to get called in for quite a bit, is when we hit that button on the dash, but the request never reaches the ECM. So of course it's never going to try to turn on the compressor because it didn't even see a request to do so. Now, this is where it can branch off into a lot of different possibilities, because every system is going to function a little bit differently. We've got some constants throughout different vehicles, but every manufacturer is going to set this up however they prefer to. And we as technicians need to be able to kind of shift gears and be able to figure out, how does this particular system work? How does the AC request get from that button on the dash to the engine control module? Because in the cases we're talking about, it's not reaching that point. So we're going to go through a couple case studies here to illustrate these points, some things that technicians have struggled with, some other players and enable criteria that are involved with making this happen. So the first one I got is a 2010 Ford F-150. Okay, there's no compressor operation. Like we mentioned, the shop has charged the AC, and I go in and verify this, of course, and I check the ECM. Of course, scan the vehicle for codes. You always want to do that. I did have a code in a related module. I'll get to that. Just keep that in mind. There was a code in this one that pertained to what we're dealing with. Although I didn't recognize it immediately, it did pertain. Anyways, my first step here is I want to go to the engine control module, or it's a PCM, powertrain control module on this particular Ford, but we're going to stick with ECM, engine control module, and I go to my AC request. It says no, okay? Meaning that, like we mentioned, the request for compressor operation never reached the engine control module. So am I going to go to my relay? Am I going to start jumping my compressor? I guess I could, but I'm not even going to bother with that at this point, because it's not receiving a request. Even if the compressor is good, the relay is good, I'm not going to bother with any of that stuff. I need to figure out, why is the request not reaching the ECM? Now, who else is involved? Where does this request come from? How does it get from the button on the dash to the ECM. And this is a big one to understand. You want to take the time here, do a little bit of research if you're not familiar with the vehicle and figure this out. And this is where a lot of techs struggle because, of course, the HVAC module is involved. That's the button on the dash, the control head. And in some cases, it's not a module if you go to manual air circuits. But most vehicles nowadays, it's going to be a control module that's on a data network. But in this vehicle and another vehicle that I talk about today, it's not the only module involved. And we need to be aware of this. You know, who are the players involved? And a wiring diagram is going to show this to you. You can also look up the system description operation and maybe it'll lay it out for you. Maybe it won't. But a diagram will definitely show you who's involved here. So if we look at the wiring diagram for this one, we have the HVAC control module. And I should mention this is automatic air in this one. So you select the temperature, hit auto, control module sets up everything else for you inside the vehicle. But there is an AC button. Okay, but we have our HVAC control module. And on this Ford, the HVAC control module sends out and receives data on the medium speed CAN network. Okay, so there's a lot of interior components on the medium speed CAN. Now, how does that get from there to the ECM though? If you look, the ECM, which is on the diagram, when you look up the AC diagram, it is not on the medium speed CAN. It is on the high speed CAN only. So two different data networks on the same vehicle. Well, how does the information get from the medium speed CAN to the high speed CAN? Of course, there's a gateway module, and this is important to know because the gateway module in this application is the instrument cluster. Okay, so the instrument cluster is connected to both the medium speed and the high speed network. Now, the reason I'm bringing this up is because I actually ran into a similar Ford F-150 a couple years back that had no AC operation, and there was no request in the ECM in that one as well, very similar to the scenario that I'm dealing with here, but everything on the HVAC module side was working just fine. It recognized the button, you know, that you were hitting the button for AC and it was sending its signal out, but it never reached the ECM. And what we ended up finding out there was that the instrument cluster, and this took quite a bit of messing around to figure this out, the instrument cluster had been replaced with a used instrument cluster from another truck, and it had not been programmed correctly to the vehicle that it was in. And if you don't program these modules correctly and set up all of the programmable parameters in these, it may not be right for the application that got put in. So what I mean by that is maybe the truck it came out of didn't have AC or something to that effect. Anyways, you have to program these clusters to the trucks. And in that case, this is a different vehicle. Of course, I'm not talking about the one that I'm dealing with right now. But in that one, that's what happened. Somebody put a used cluster in there, didn't program it correctly. And so the AC request never made it past our used instrument cluster to get to the ECM. So we had to get it programmed it correctly, and then it sent its request when you hit the button and the AC worked. Okay, so back to our vehicle that we're actually on. I have this, in my mind because it's a very similar truck to what I had dealt with at that point. And in both cases, when you hit the button on the dash, the little AC lights up, right? It's not blinking. Sometimes you'll see a blinking light when you hit that AC button, and that can indicate to you right away that the HVAC control module has an issue, but it wasn't the case in either of these. Okay, so I have that in the back of my mind that maybe we need to program this control module, the instrument cluster, but I'm going to keep looking before I just decide to do that. So I did mention that there was a code, and we want to be vigilant for codes and do an all system DTC scan because, like what I'm getting at here, you never know what modules are going to be involved. I mean, you should know, you could look this stuff up, but when we're just hopping onto a vehicle, just consider there could be other modules involved in this AC request that maybe you wouldn't think of right off the top of your head. Anyways, in our HVAC control module, I do have a B10, B9, which lists as a blower control circuit fault. Okay. Now I asked myself right away, does this have anything to do with the AC? I'm not sure. I did test the blower motor and I went through all the speeds and it did function on all the speeds. Okay. Now, does this have something to do with the air conditioning not operating? I'm not 100%, but let me go off of on another little sidebar here as to why I'm really considering this code as a potential problem. Actually, the vehicle I drive every day is a 2010 Ford Transit Connect. Okay. And I have actually been called into a shop for this as well. The Transit Connect, at least mine, just uses a manual HVAC, meaning that the HVAC control head is not a control module. It doesn't communicate on a network. It's just some switches, right? There's a blower speed switch, there's a mode switch, and a temperature switch. And actually, one of those might be a cable. I don't know. But either way, it's not a control module that sends out a request onto a network. It's a physical switch that's going to close a circuit. But here is the other thing that's involved with this system. There's a blower motor resistor, a traditional, series resistor that's going to add resistance in series as you change the blower speed on the dash to either slow down or speed up the blower motor, right? Very, very simple circuit that we've all dealt with for many, many years. Actually kind of old school at this point. Most of them are using a transistorized control to adjust blower speed. But anyways, what happens in these vehicles is the blower motors will open up. Of course, that's not unique to Ford Transits by any means, but here is what is unique and what shops kind of miss because there's no codes when this happens. You have to understand how the system works. Once you lose one or more speeds, and it's generally going to be the lower speeds of the blower motor, not the high speed. Once you lose these lower speeds, because the resistors just open up on the resistor card, very typical, nothing special here, there is a feedback circuit to your ECM that verifies that the blower motor is working, and it uses a circuit connected to this resistor. And I'm not going to go through all the details of the circuit because really you have to see it to understand, but here's the deal. If these resistors open up, it loses its feedback and it basically infers that the blower motor is not on or not functioning. Because, and it is, right? Maybe you lost some speeds, but you could have it on high speed, blower motor's turning, the ECM does not see the feedback. So it thinks, okay, well, the blower's not on. I'm not going to turn on the compressor. And that's built into Ford's strategy. No blower operation, no AC compressor, even if I do see a request when the buttons hit. Okay, so the fix there is to replace the blower motor resistor. So you get a Transit, you get an AC that's not working, check all your blower speeds. And I'm sure there's some other Ford models that applies to as well, but I've had a couple call on the Transit Connects where that's the case. And it's not, I guess, intuitive. I mean, it makes sense. Why would we run the compressor if the blower motor's not working? But it doesn't really jump out at you with codes or anything like that, but it is something that you want to keep in mind. So going back to our Ford F-150, and I know I keep going off track, but I had a lot of various vehicles and points I wanted to make here with this. Going back to this vehicle, I have this code, which again states B10, B9 blower control circuit fault. And I tried clearing this code out and it popped back immediately. It was there. Again, I verified all the speeds of the fan do actually function. It doesn't lose one, but it sets this as a hard fault in the HVAC control module. So I did a little bit of reading on this code because I'm suspecting this might be inhibiting my AC request from going out, but I'm not 100%. But from what I found reading on Identifix, that was actually the case with this code, is that when it's present, the HVAC control module will not send out an AC request, even if you hit that button and all the other conditions are correct. Okay, so we need to fix this code. This is basically where I need to go before I proceed any further with the AC diagnostics. So let's check out the actual blower speed controller, they call it. It's a blower motor resistor, if you want to call it that as well, but it's transistorized, right? This is down on the HVAC assembly, right below the glove box, pretty easy to access. And it's very simple. It has a power in, it has a ground in to this. You could consider it a module, but blower speed controller. So it's got a power feed in, it's got a ground in, and then it's got a ground that feeds the blower motor. The blower motor receives constant power. This blower speed controller is going to pulse width modulate the ground side to regulate the speed of the motor. Okay, and the last circuit that goes to it is a signal wire that is going to be pulse width modulated from the HVAC control module to tell the blower speed control motor how fast to run the motor. All right. Now, this circuit in particular is the one I want to pay attention to because, again, the blower motor is working. So I guess I can assume, and I'll check, but I can assume the powers and grounds to that speed controller and the fan are working because the fan works. But I want to check this pulse width modulated circuit. Now, again, I could assume it's working because when I change the speed command, the blower speed actually does change. Well, from what I found, everything looked correct on here, but I still get this code. And this code is, again, referring to basically this circuit, because this circuit, this command wire from the HVAC control module to the blower speed controller is really the only connection between those two. So it's the only thing that would set a code. And what I have actually found on these trucks before is that aftermarket blower speed controllers will cause this code to set. Something about the feedback, something about that circuit is not what the HVAC control module is expecting. It's very sensitive to the voltage being correct on that circuit. And if it's not, it sets this code. And I just happened to see when I'm looking under here and testing that this blower speed motor had been replaced. And they also replaced the pigtail and the connector. And I verified that they got the wires correct. They did, but this is an aftermarket blower speed controller. So the fix here is getting one from Ford, a Motorcraft blower speed controller, to replace it and clear the code. And they did that, and the AC actually turned on and it worked. So that was the fix. So again, a B10, B9, indicating that there's an issue with the blower speed controller. Keep that in mind on Fords, is that anything that interferes with the blower motor, or its perceived operation anyways, will inhibit the compressor from turning on. So that's that one. Pretty easy fix. Not anything too complicated, but I wanted to make that point about blower operation. Okay, on to the next one here. It's a 2010 Chevy Silverado. This one also has automatic air, and it also has no compressor operation. The system has been charged by the shop. And what the shop ended up finding is they recognized that, there was an electrical problem, something going on with the compressor. And what they found was the underhood fuse box houses the relay that operates the clutch on the compressor. And they told me if they push on this relay, the AC clutch relay, they can get it to turn on. So they replaced the relay, same thing. Then they replaced the fuse box, the underhood electrical center, on the driver's side under the hood. They replaced that, same thing. Compressor won't operate unless they said you push on this relay. Okay, so I get to the shop and I'm like, can you show me what you're talking about? Now, as soon as I saw the tech do this, I was a little suspicious. It wasn't that he was just like pushing down on this relay. He was pushing the relay almost to the side. It was leaning. He was pushing it so hard. And then the compressor would kick on. And again, I was kind of suspicious here because he's like almost pulling two of the legs out from their circuits. And I think what he was doing was actually pushing the plastic housing of the relay so much that it was making contact internally and turning on the compressor. Either that, or maybe inside of the fuse box, maybe he was making contact with another circuit. I don't know, but he was kind of creating this compressor operation. What I ended up finding was that the computer was never even trying to turn on the compressor. He thought it was a connection issue with the relay or the fuse box, and that wasn't the case. If the relay is in there correctly, and again, it's a new relay, new fuse box, the command was never sent to this relay. So again, let's back up just a little bit here. I saw that, so I'm like, okay, let me hook up and see what's going on here. Now I scanned this one for codes, and there were no related DTCs to what I was dealing with. But again, I'm going to start with my ECM engine control module and see, is it even trying to turn on this compressor? And it said no. It said command for the relay off and request no. So the engine control module is not even getting the command or the request to turn the AC on. Okay, so really, I'm not worried about that relay at all. And it kind of confirmed what I thought when I saw him push on it, that he's creating something there that has nothing to do with the actual problem. And I think once they saw that, they never bothered looking at request. They just thought there was a connection issue there. So I want to figure out what's going on here. So again, who are our players? Who's involved in making this AC request get to the ECM? Now, of course, we've got an HVAC control module in the dash. But again, much like the Ford, it's not direct from the HVAC control module to the ECM. The ECM is on the high-speed CAN, and the HVAC module is on the single-wire GM LAN network, so two separate networks. In this case, the body control module is our middleman. It's our gateway between these two modules. So the data will be shared between the two, but it is across a gateway. So we want to keep that in mind. Again, like the instrument cluster on the Ford, there could be an issue with the data being transferred from one module to the next. But I'm going to start with the HVAC and see what's going on there. Okay, when I hit that button, and the light actually lights up solid when I hit the button, but when I hit it, what's happening? Is it sending anything out? So again, no codes in this module, but I'm going to access the data stream here and see what's going on. Now you can see a data PID. When you hit the AC button, it actually recognizes that the button is pushed. And there's actually, they break down the data PIDs into sections. And one of the sections for these GM HVAC modules is AC permission. Okay, so that's saying, are we allowing AC to happen? Have we met all the enable criteria? And if you go in here, there's some very useful data PIDs in the HVAC module to tell you, is our enable criteria met, even after we've hit the button. And these are going to be data PIDs like AC head pressure, which is interesting because the pressure sensor feeds the engine control module and then is sent over the data network through the gateway module back to the control head. And then it in turn perceives the pressure through the data transfer over a network. It's not actually using a pressure sensor connected to the HVAC control module, if you followed me there. But the HVAC control module is getting a signal. It is getting what the AC pressure is, and it needs to be to a high enough point in order to operate the compressor. Well, that says normal in my data PIDs. Okay, and again, the system's been charged, but that means that data is getting there and it's recognizing that the pressure is good. The other one is ambient air temperature, right? And again, we're looking at what is the temperature outside. If it's 10 degrees, we're not going to run the compressor. Right? But it was really, really hot this week. It was 90 plus. So obviously we should be operating the compressor. And it says, I don't remember if it actually read the temperature or if it said normal. I think it read the temperature there and it said, whatever the outside temperature was. Battery voltage said normal. Okay. If the battery voltage is too low, it will inhibit the compressor from running. Engine coolant temperature. Again, and these are a lot of these, this one specifically is going to be bussed in over the network, but it says normal. So everything says normal on this AC permission list, but it'll say AC permission or AC request, it said withheld. Okay, no matter what I did with the button, engine running, pressure's good, it says withheld. So I've found where my issue is that the AC control head is withholding compressor operation, even though I've hit the button, but none of the data PIDs indicate why. And I think this is kind of maybe a fault of GM to not include another enable criteria that is a big part of compressor operation. And I was wondering about this because I didn't see it on the list and everything said normal. I'm like, why would it withhold if everything is good? And again, no codes. But here's the other one that a lot of techs forget about. And it might have something to do with the type of vehicle you work on. You know, if you work on specific vehicles that have this sensor, you're probably very familiar with it, but if you don't, you may not even know it exists. And here's what this is evaporator core temperature sensor. Now, not all systems use this. There's quite a few that don't. They don't have a thermistor that's actually put in the fins of the evaporator core, but some do. This particular truck does. Some other ones, that I've run into in the past. Ford Fusion, very, very common for these thermistors to open up, and it actually sets a code in the ECM because the ECM in those monitors the evap core temp. Okay, and it sets a code, you pull the dash, put a temp sensor in there, and you're good to go. Another one I ran into about a year ago or so was a Saturn Vue. Now this one was odd because the temp was just skewed about 30 degrees, right? So if we look at the evap core temp and we look at the ambient temperature or the temperature inside the vehicle, it was 30 degrees off from where it needed to be. And we checked the resistance of the circuit. It was good. It was actually the thermistor that had been skewed. And because that temperature was off, it was not operating the compressor correctly. Because the goal of this evaporator temperature sensor is obviously to measure the temperature of the evaporator core, but it's to keep it from freezing, right? Because we don't want the temperature of that core to be too cold, or the condensation from the water that's, condensing out of the air would actually freeze up. And if it freezes and creates an ice block on that evaporator core, it's not going to be able to cool properly. So we have a target temperature that we want to keep that evaporator core at just above freezing. And that sensor is used there. Of course, there's other ways to do that, but in some cases we use a thermistor. It's just like a coolant temp sensor. Really, really easy circuit to understand. We have a 5-volt reference that's coming out of the control module. There's a fixed resistor inside that control module. That 5-volt will drop across that fixed resistor, and then it will drop across the thermistor, which is a variable resistor. And in between those two resistors, we get a varying voltage because of the varying resistance of the thermistor, which reacts to temperature change, right? So the control module looks at that voltage and interprets that voltage as a temperature. That's it. So just a changing resistance based on temperature, changes of voltage, which the control module then interprets as the temperature of the core and is going to react accordingly. So again, I kind of went off on a couple different vehicles there, but this is another one that I wanted to bring up for everybody because it does get missed. And this one's easy to miss because there's no code, and it doesn't even include this data PID in the list of AC permission. Which I thought was kind of odd. That might not be the case on every single Chevy truck, but this one, that's how it was set up. You have to back out, go into a separate data list, which includes the AC system sensors. Okay, and I think there was one that said inputs too, but the sensors is where I found this. Now, this particular application is an auto AC system. It's dual zone. It has several temperature sensors. So don't get fooled. There are a number of them inside of the vehicle and the ambient temp sensor. But the one we want to look at here is the evaporator core temperature. Now, when I went in, I looked at this. It said -40. Okay. Now, I thought this was odd that there was no code, and I don't really have an answer for why there wasn't a code because there should have been a code in this case. There should have been some sort of rationality or circuit range, but there was nothing in this module. But it said -40. So I found my reason that it's withholding AC request because it thinks the core temp is 40 below zero. And now I just have to figure out why. Okay, so is this like a Ford Fusion where the thermistor is opened up? And anytime on any thermistor circuit that I've ever seen, if you see -40, and oddly enough, -40 is the same in Fahrenheit and Celsius, but if you see -40, think open circuit, right? So that 5-volt reference that comes out, if we open up that circuit, there's no current flow, there's no voltage drop, meaning that the computer's gonna read 5. high voltage equals cold temperature in these setups. And that's a coolant temp sensor, that's an ambient air temp sensor, an evap core temp sensor, whatever temperature sensor you're dealing with that I've ever seen. I could be wrong. They could have another setup out there somewhere, but in just about everyone that I've ever seen, an open circuit equals cold or negative 40. So that's what I'm thinking right away. Okay, well, this is easy enough to find out. So I unplug the connector, and both wires for the temp sensor go to a connector on the control module. And I unplug it and I ohm these wires. I just use my ohm meter, and it measures 8,000 ohms. Now, I did some digging and some research, and I found out for my temperature that was accurate for what it should read at the given temperature, about 90 some degrees. I should have 8,000 and some change ohms. So that indicates to me that my temperature sensor is actually intact, and all the wiring to the module is as well. Okay, so I plug the module back in, and I back probe on our signal wire for the evaporator core temperature sensor. I just back probed, I have the key on, and I measure 0 volts on this wire. And I thought that was interesting because it's reading negative 40, which in my mind means open circuit. I should see 5 volts there, but I don't. And of course, I did ohm the wires right from the connector, and everything looked good there. But for some reason, the 5 volts is not coming out of the module. Okay, so what does that mean? That means there's an internal issue with this module, right? I'm going to check powers, I'm going to check grounds. Everything checks out there, but it is not sending, the 5 volts is not reaching the signal wire to go out to the sensor. Everything else is intact. And I checked pin fitment and everything, but somewhere on that board level, there has to be an open, because the computer's still seeing 5 volts, but it's not reaching the pin, it's not reaching the circuit, and so it can't drop anything below 5. It's going to register a negative 40. Okay, so what's the fix here? This thing needs an HVAC control module. And these do have to be programmed, but it's easy enough to do. GMSPS, put a control module in, good to go. AC turns on and works just fine. So that's all that I've got for you today. Hopefully you enjoyed that, got something out of that, and hopefully it's not too hot where you're at, or if it is, hopefully your air conditioning is working just fine. But I want to thank everybody for listening. I do have some guests lined up for the show in the coming weeks. I've been trying to get some people on the show and just fighting through some scheduling conflicts, but we are going to have some great guests coming up in the near future. So stay tuned for that. But other than that, let's get out there and start fixing the world one car at a time.